Okay, we are going to discuss after discussing switching fabrics. We are now moving to discuss that in as we have discussed that when the arrival rate when the when the packets that arrived at an input port, if its arrival rate is higher, then the rate at which the packets are forwarded from input port to output port using switching fabrics. That is, if the packets are four packets arrive at a moment in a second. For example, four packets arrive in a second at an input port, and two packets are forwarded, or suppose one packet is forwarded by switching fabrics from input port to output port. So three packets will be stored in the queue. Okay, so input port queuing, that the queuing can occur at input port. If the packet arrival rate is higher than its processing, then some packets will be queued in the buffer. Okay, so if the fabric is slower than input port combined, then the queuing may occur at an input port. That is, this switching fabrics, it is slower than these than the data arrival rate at the input port. Then the packet, that is the packet that are arriving in input ports, they are higher. For example, four packets arrive at a time in a second, and one packet is forwarded by switching fabrics. Then the three packets will be stored in the queue in the input buffer. So it can have, therefore, if the packet is stored in the queue, then the queuing delay and loss due to input buffer overflow. Then if the packet arrive and there are more packets and there are other packets stored in the queue, for example, then when this blue color packet arrives, the red color packet is already stored in the queue, so this packet will be stored in the queue. So it will has to wait. First this red packet is transmitted, then the blue packet will get its transmission. So it means that it has to wait. And when a packet arrives and the packet, then the and this queue is full, then this packet will be discarded. So when there are packets in the queue, then this can introduce queuing delay, as well as it can have the packet loss if the buffer is overflow. But despite these two phenomena, there is another important problem that is called head of the line blocking. Okay, head of the line blocking, what does it mean? Suppose we have received these five packets. Two packets are received at input port this, one packet is received at input port 2, and two packets are received at input port 3. Okay, and these are this its order. Now suppose that the for this red one and this red one, the outgoing port is this one. Okay, so we know that only one packets can be transmitted at a time. Suppose this packet is getting transmission, for example this packet is transmitting, so this packet will wait. You can know that this packet, for example, we have a switching fabric technique that that enables that if two ports, they are sending packets to two different ports, then those packets can be transmitted at the same time. Suppose this red one and this blue one, they are going to different ports, so they can be transmitted at the same time. Now suppose this red one and this red one, they have same output port, so one of them can be transmitted at a time. Suppose this one red is going to be transmitted, then this red one will have to wait. Now behind this red one packet, there is one green packet that is waiting, and this green packet is for the output port green one. Now this packet can be moved at this time. When this packet is moving to this output port and this packet is moving to this output port, this green packet can be moved to this green output port, but it cannot be moved. Why? Because there is one packet waiting. The red packet is waiting in the queue. Okay, so this is called head of line blocking. Although this packet can be transmitted, this output port is free, this packet, and this is not conflicting with other transmission, but this packet cannot be transmitted because this packet is waiting in the queue, and this packet is waiting in the queue. Why? Because there is one already written packet that is going to be transmitted in the to the output port. This red packet is transmitting to the red output port, so this red packet has to wait. This is called head of the line blocking. Okay, now so you can see that this problem happens in the this is called so head of line blocking. It usually occur in the input port, not in the output port. Okay, now when the packet is now we have discussed that when the packet is arrived at input port, okay, it is stored in the input port, and then the packet header is examined and the forwarding table is looked up. Okay, after matching the output port and the forwarding table, after finding the output port for the forwarding table, then the switching fabrics forward the packet from input port to output port. Okay, so now the packet is moved to the output port, then also the packet can be stored in the buffer. There is a buffer. Why? If the switching fabric is transmitting 4 packets in a second, suppose switching fabric is moving 4 packets to the output port, and this link has the bandwidth of 1 packet transmission in a second, then 3 packets will be stored in the queue. Okay, so the queuing also occur at the output port. Why? Because if the switching fabric rate is higher than the output port bandwidth, output port transmission rate, then some packets will be stored in the queue. So buffering is also required when the datagram arrives from the switching fabric faster than the transmission rate of the outgoing link. So whether the buffering is happening in the whether the data is buffered in the input port or in the output port, so it means that so we have scheduling discipline. Scheduling discipline means that if we have 4 packets here in the queue and the link, and we can transmit 1 packet at a time, so which one packet should be transmitted? Either first come first out or priority based or so on. So we need queuing discipline. This is called scheduling or queuing discipline. We choose among many queued datagram for transmission. Okay, since as you know that here 2 packets are stored in the input queue. Okay, now we can transmit which one packets at a time. Okay, if you want to transmit the packet from this input port to output port, then which packet should be taken into consideration? So which packet should be transmitted first? So either first come first out or the priority base. Okay, so we have scheduling discipline. So the data packet can be lost due to congestion or lack of buffer. Why? If the packet is arriving faster than the transmission rate, then such packet will be stored in the queue, and when the queue or the buffer become full and more packets arrive, then those packets will be discarded, it will be lost. Okay, so we need a very efficient scheduling scheme that can perform. We need some priority scheduling who gets best performance and network neutrality. Okay, so sometimes some packets have higher priority than other packets, so the higher priority should be given more priority. Okay, so we will discuss it through example. Now the output when the output queuing occur in the when the queuing occur at the output port. So for example, you can see that this is the packet arrival rate at the input port. So the buffering is also occurring in the packets are buffered in the input port. Similarly, here you can see that in this output port it receives two packets. So so these are stored in the queue. One packet will be transmitted, one packet will be stored in the queue. Okay, and this output port is free. Okay, so buffering, when arrival rate exceeds the switch exceed output limit, then the packets have to be buffered. Okay, this, and when the buffer is full and the more packet arrive, then the buffer overflow occurs and those packets will be discarded. Okay. Now this is the formula that how much buffering we needs. So we will not discuss it. Now we are going to discuss scheduling mechanism. Okay. The scheduling mechanisms, these can be we can have different scheduling mechanisms. So we are going to discuss some of the approaches. Okay. The first one is called FIFO. This is called first in first out. That the packets, they are stored in the queue as they arrived. Okay, when the links becomes free and we want to transmit packet, then we will transmit that packet which has the first priority. Okay, which has come earlier. Okay, so the first it will be transmitted. Okay. So this is we can have a real world example. If you are if more than 2% arrive in a bank, so the one who has come the first, he will get the its turn first. Okay. Similarly, if this buffer becomes full, this buffer is full and more packet arrives, so we have to discard. So which packet should be discarded? Either the arrival packet should be discarded, or so we have this different discard policy. If the packet arrives to the full queue, that if the packets have arrived, 4 packets have arrived, and this buffer is full, then who to be discarded? So tail drop means they dropping arrival packet. These arrival packet will be discarded. Priority means that we will select which packet have the lowest priority among the arrival and the stored one. So those one which have the lowest priority, they will be discarded. This is called priority base. Drop and remove on priority base. Random base means that we will select randomly among these arrival packet and those stored packet. We will drop 3 packets that have randomly. Okay. So we have different discarding policy as well. Similarly, when we have a priority scheduling policies, that is, for example, when the packets they arrive at an output port and they have to be transmitted, then the packets are of different classes. Okay, for example, this red one and this blue one. Suppose the red one, it has higher priority and the blue one, it has lower priority. And how the packets can be mapped to different classes? So we can define the classes based on destination IP address, destination port number, etc. For example, those packets that have the destination port number 80, they should have the higher priority. Those packets that are other than a port number 80, they should be low priority. Okay. So when the packets are arrived, so these packets are stored in different they are divided into different classes. Okay, and then now in the priority scheduling, when we take the packet from the higher priority, for example, this packet, when this link is available and we want to transmit the packet, so we will transmit first the packet from this class, from the queue of this the packets of higher priority. These will be transmitted first. When these all packets are transmitted and now this queue is free empty, then we will transmit the packets from this queue. First come first serve base. Okay, so this is called priority one. So let me explain it through an example. Suppose packet 1 is arrived. So when packet 1 is arrived, so it get its service. Okay, that is to be processed and then it will be transmitted. Okay, because there is no other packet. Suppose packet 2 and 3 arrives, then they will have to wait. First this packet 1 has to be transmitted. Okay, because this is in service. Okay, So this packet 1 is transmitted, and now after packet 1 is transmitted, we have packet 2 and 3, because since this red one, the packet 3, it has higher priority, so it will be processed first. After it is transmitted, then packet 2 will be processed, and then packet 2 will be transmitted. Okay, and when packet 4 comes, then packet 2 is in the service, so packet 4 has to wait until and unless the packet 2 first gets its transmission, then it will start, then the 4 will be transmitted. Okay, so in this case we know that when the packet arrives, so they are stored in different queues depending upon their priority, and when the link is free, then we first take the packet from the queue of higher priority. When all of these packets are transmitted, then the packets from the lower priority queue will be transmitted. Okay, we have another mechanism that is called round robin scheduling. What does it mean? That, for example, the arrival packet, they are classified into 3 categories. This is with the higher priority, this is with the lower priority, and this is with the lowest priority. So when the link is free, we take one packet from each queue. First we will transmit the packet from this queue, one packet. After this first packet, one packet is transmitted, then we will transmit one packet from this queue, then one packet is from this queue, and then we will go to this. So in this case, so in the last example, if you remember, so we were transmitting the all packets from the higher priority, then we will transmit the packets from the lower priority. But here in round robin, what we have, that we first transmit the one packet from higher priority, then from lower priority, then from lowest, and after this we again transmit the next packet from the higher priority, then next packet from lower priority, and then from next. Okay, and round robin scheduling, we have multiple classes. We cyclically scan class queues and sending one complete fragment from each class if available. Okay, so real one example, it can be like, for example, if we in a bank, we receive the queues for young people, for female, and for the old people. Okay, so aged people, so we can have 3 queues for female, for young, and for aged. Okay, so we can take one person at a time from each queue. Okay, similarly we can have weighted fair queuing. What does it mean? That when for example, we have when the packets are arrived, they are classified into based on its classification. The packet is either stored in the higher priority, lower priority, or the lowest priority. So when the packet is to be transmitted, so in this case we assign more W1 weight. W1 weight means, suppose we transmit 3 packets from this higher priority, then 2 packets from the lower priority, and then 1 packet from the lowest priority. Then we move again, we transmit 3 packets from the higher priority, 2 packets from lower, and 1 packet from lowest. So in this case, when a packet from each class, we transmit different number of packets at a time depending upon the weight. This is called weighted fair queue. So it is a more generalized round robin mechanism, and each class gets weighted amount of service in each cycle. For example, when in first cycle the 3 packets are transmitted of this from this queue, and 2 packets from this, and 1 packet from this queue. Okay, so this is a more generalized way. So we have discussed up to now the router structure, and now we are going to discuss the internet protocol, and we will discuss its what is internet protocol and how it works. So we will discuss it in the next slides.